Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hegazy from SEG CAD Solutions. Today, inshallah, we will make a demonstration for kettle TEMA heat exchanger type. And in this demonstration, we will generate the 3D model of this equipment. We will divide the demonstration to three parts. The first part will include the 3D modeling of this equipment. We will open a new project and name our project. After that, select the location of this project, select the module type, which is heat exchanger. After that, click finish. SEG will start generating the project files. We will select the equipment and rename it. After that, from the setting, we will open the equipment setting and modify the visual setting and the other data. And from the app setting, we will select parent preview, child preview, and the size of nozzle shall be indent instead of NBS. Now we will add an elliptical head. Define the inside diameter, the thickness and straight flange minimum thickness after forming, and click save. Now we will add another part which is CAN1, and from CAN1 we will select shell type, define the inside diameter, define the thickness, the longitudinal building line orientation, and the length of this shell. Now we will add a designed flange for heat exchanger. We will select the second type, which is integral weld neck with grooved face, define the inside diameter of this flange, the thickness of the end and the neck thickness, the neck length. After that, we will define the outside diameter of the flange thickness, the raised face thickness, the raised face outside diameter, the bolt circle diameter, and the bolt diameter. After that number of bolts, we will click save. Now we will start creating the assembly. Now that's the ellipsoidal head, the can, after that the flange. This is the designed flange. Now we will add a gasket with a pass partition, select two passes. After that, we will define the inside diameter, define the thickness, and define the width of this gasket, define the pass partition thickness. Let's add the tube sheet. From the tube sheet, we will select the first type, which is gasketed from two sides, define the inside diameter, the raised face from two sides, the thickness of the raised face, the thickness of the tube sheet, select number of pass partitions, define the pass partition width, and the fillet. Now let's click save and generate the 3D model for the gasket and the tube sheet. After creating that, we will add the hole pattern. From here, we will define the dimensions of the tube pattern, like inside diameter, tube outside diameter, tube clearance, select number of pass partitions, and the vertical and horizontal pass line, define the tie rod diameter, select the hole definition on the tube sheet for the tube. After that, select the tube pattern. Okay, now we have the tube pattern. We will remove this tube and convert this one to a tie rod, add another tie rod at the bottom of the same location of the first tube. Click save. Let's add another tie rod, define the location, and in Y and X. Let's add another two passes on the pass partition, define the Y to be at 0 and the X to be 320 with a negative and positive value to add tie rods. Now we saved the information. Now let's add a baffle. Support baffle. Let's select end baffle, define the inside diameter of the shell, define the clearance, no cut on the middle, define the spacing and the location, define the vent hole and number of baffles. Now let's add a tube. Select, after creating it, let's select bend tube, not a straight tube. Okay, now let's add a tie rod. Let's define the length. Thread length at the start, not offset. Thread at the end. Tie rod penetration, diameter of the tie rod. Now let's create the 3D model for those parts, baffles, tube, and tie rod. Now let's, after creating the 3D model of those parts, let's create the pattern for them. Let's select the tube sheet and tube sheet holing and click on start holing. Now SEG will start creating the tube pattern holing and define the pattern of 4 tubes. After that, we will make a cut on the baffles and make a pattern for the tie rods. Okay, now we will open the assembly of the baffle. As you can figure, some tubes need to be updated. Just double click on it and double click on the sketch pattern. Just double click on it and click save, not move. It will be updated. This issue related to Autodesk inventor itself. Now we will make a constraint for the UCSs of those tubes. Automatically, it will not take more than 30 seconds. Let's make the UCS constraint. By that way, select the tube UCS and make assembly with the UCS or the final assembly of tubes. Now we will save the tubes assembly. Okay. Now let's add a sliding bar and select the suitable type, which is double radial. Define the inside diameter, define the thickness, the clearance, and the length. Define the height, location, orientation, and in-between angle, which is the contact angle between the double radial sliding bar. Click on assembly to start creating the sliding bar assembly. Now it's okay. Let's add the other parts. Let's add a gasket after the tube sheet. Define the inside diameter, thickness, and a gasket width. Define another flange, and we will make it looks like F1 during selection. Let's add another can, which is can 1, and make it looks like can 1, and define the length, change the longitudinal welding line orientation and the length. Let's add eccentric cone. So from here, let's select the type to be eccentric, define the inside diameter, the thickness is 28, longitudinal welding line orientation, the length and the other diameter on the other side. Let's add another can 3, select shell type, define the inside diameter, thickness, longitudinal welding line orientation, the length, and click save. Let's add the last main part, which is the right head. And let's select ellipsoidal head with crown and the knuckle radius. And from here, define the inside diameter, the thickness, and the straight flange minimum thickness after forming. Now let's make a quick check for the crown and the knuckle radius calculation. Okay, that's the crown radius, and that's the knuckle radius. Okay, let's run the assembly. Here we have the gasket, the other flange, the shell, the eccentric cone, the main shell, and the last head. Now you can figure that the head convex direction is not correct, so we will flip it and run the assembly again to flip the head direction. Okay. After that, we will select the cone and add the saddle on the eccentric cone. From here, let's define the height, define the thickness, and for the wear plate, define the contact angle, define the width of the wear plate, define the thickness. Okay, and from here, let's define the top width of the saddle and the bottom width and the mid rib. And from here, let's define the base plate length, base plate width, thickness, and the hole diameter, the hole offset from the short edge, hole offset from long edge. Add another row, define the location, and click save. Now let's add another saddle for the main shell. Okay, select the saddle. From here, select the contact angle, define the whip width, the base blade length, base blade width, thickness, hole diameter, offset from long and short edge. Add another row, define the location, define the top width of the saddle, bottom width of the saddle, add mid row, and now let's create the assembly. Now we can figure the parts are created automatically and assembled automatically. That's for the first saddle on the eccentric cone. the second saddle. Now let's add a lifting lug for the bonnet. Here define the bottom width and all dimensions of this lifting lug according to the image on the right hand side. Define the location, orientation, click save. Let's add another lifting lug and we will make it looks like this other lifting lug, but we will change the location and only the orientation. Click save, select can 3 and add a lifting lug, type 2, define all dimension, add a wear plate, define the wear plate dimensions, define the location and the orientation. Let's add another lifting lug and make it looks like lug 3. Change the orientation and click simply. Now you can figure that the wear plate width is or the length is not need to be increased a little bit. So after finishing the assembly, we will come back to SEG and modify the wear plate width for lug 1 and lug 2. So we will increase the width, the length, and here the same. Let's add a nameplate. Select can 1 and select nameplate to add a nameplate. And from here, select the first type, define length and width for the bracket, define the projection and location, add an ASME nameplate, define the dimensions, and click simply. Now the wear plate for lug 1 and lug 2 will be updated and the nameplate will be created. Okay, now let's add some let's add a stiffening ring for can 2. Define the height, select ring blade and define the height, thickness, and the location. Let's add a nozzle for the bonnet. Let's add T1 and select the size. It's 3 inches, scalable 160. Define the location and a wear plate with 15 millimeters and width and 18 millimeters thickness. Define the name of this nozzle or the service of this nozzle. After that, we will add a flange, select rating, size, and scalable. After that, we will come back to the nozzle and add the nozzle load, define the forces, moments, click done, and from the calculator, we will define the projection from the center line to the facing of the flange, define the fillet dimensions, and you can check that the loads and nozzle information is correct. Now, let's add another nozzle, T2, and from here, we will make it looks like T1. Sorry, let's define the name of this one, define the size 4 inches, define the scalable, wear plate width and thickness, define the location and the orientation 190 degree. So for the flange, we will change the size and scalable. Okay. Define the nozzle load to change it for the 4 inches nozzle. Define the projection. Now let's define the welding details for nozzle T2, and you can figure that the loads and the nozzle information are changed. Now let's create the assembly to start creating the nozzles. The stiffening ring. Now, after creating those elements, we will add some other nozzles. We will add N1 to can 2. After that, select the size, schedule, define the name of this, the service of this nozzle, find the location, and let's add a flange for this nozzle, N1 flange. Select type, schedule, ratings, and size. Click save. From here, let's define the nozzle load for the 2 inches nozzle, forces and moments, and define the projection from the center line to the facing of the flange. And Let's define the orientation to be 190 degree. Let's add another nozzles into to CAD 3. Select the size 3 inches, schedule 160 degree, 160. Let's add a reband, define the surface of the nozzle. Click save. Let's add a flange. Defined the type, rating, size, and schedule. After that, we will come back to the nozzle and edit the nozzle load. Click done, and from the calculator, let's add the projection from the center line. And from here, we will define the welding sample. Click save. Let's add another nozzle in 3. Select the same options, which is select the type of the nozzle, select size, schedule defines the surface of the nozzle, define the location. After that, we will add a flange to this nozzle. Okay, after that, we will modify the projection, and from set weld, we will modify the welding information. Let's add another nozzle in 4, and let's make it looks like in 3, and let's add a flange in 4 flange, and we will make it looks like in 3 flange, and select N4 again to modify the location and click save. Now let's add N5, and this nozzle will include an elbow. Let's select the size as a 1 inch, schedule to be XX strong. Define the surface of the nozzle as a level indicator 1. Save. After that, we will add an elbow, so N5 elbow. Let's add this element. Select 90 degree long radius and the orientation. Let's define the projection from the center line to the center of the elbow. Define the welding sample, and from here let's add a pipe. So N5 pipe. Select the size as a pipe, schedule and define the length. Let's add a flange. So N5 flange. From here select size, schedule, rating. Okay. So let's create those elements. Now after finishing the nozzles, let's complete the other nozzles. Let's add N6 and let's make it looks like N5. Let's add another elbow, N6 elbow. Make it looks like N5 elbow. Let's add another pipe to N6. For that, make it looks like the same pipe of N5. Let's add another flange and make it looks like N5 flange. We will change the location and orientation of N6 and the surface, and for the elbow we will change the orientation. Let's add another nozzle N7. Okay, by the same way we will complete the other nozzles. So in this video, we will make the 3D model as we discussed on the beginning of this video. And for the second video or the second part, we will create items which they are not included on SEG library. For example, like the baffle support, we have and internal support for the baffle. Like earthing bows, we will create it and add it to the model, and we will know in the second part how to create those items and how we can add it to SEG bill of material to make it appear on the final drawing. The third part will include the generation of drawings, how we can generate the general arrangement drawing, the sub-assembly drawings, detailed drawings for saddles, baffles, tube sheet. All of that we will know how to create it on the third part. Now that's nozzle N10. Define the service of this nozzle. And let's add the last nozzle, which is N11. We will make it looks like N5. Add an elbow to this nozzle. And we can make a nozzle looks like a nozzle if we have some attachments to this nozzle by using the group option. The group option gives you the ability to make a copy for a lot of elements in one time. There are reference reference videos for this, and you can check the group options. Now let's create the 3D model for nozzles. Now all nozzles shall be created. Okay, now we have the final model. Let's add let's add a stud bolt to connect the flange N1 and F1 and F2. Okay, from here let's select ISO knot type, define the size to be 36 millimeters. Define the spacing between knots and the length of the stud bolt. Now we have the stud bolt. Now let's make some modifications for the tube sheet and baffle. Let's open the tube sheet, and you can figure that because it's a tube, it's a bended tube, we have holes on one side only, so we will make a mirror for the tube pattern. Okay, click Save. The same thing we will do it with the baffle, so we will open the baffles simply and open the baffle part, make a mirror for the tube holing. Now we will make the cut for the sliding bars. So let's create a sketch here. This part will be done manually, which is making a cut for the sliding bar on the baffle. Okay, let's open the baffle and modify the sketch. Convert it to construction line, and let's add a rectangle. Make those lines are parallel. Define this offset. Let's add another rectangle, and we will make the same dimensions by using the equal constraint. Now we will make extrude cut for those through all, and in the two sides let's make a chamfer at the ends right here and click OK. Now we have the final model of the kettle type.